So let's talk about section 4.2, combining functions and composite functions. As we take a look at functions and their composite functions, one of the things that we are looking at while we're doing this is finding the sums, difference, products, and quotients of two or more functions. We're also going to talk about the average cost of functions and then the composition of them. So with the first things first, since we're dealing with functions in general, let's just give ourselves a quick reminder of one or two things. So the first reminder is that remind yourself that if we use the word g of x, that this is basically just a function, okay? And if I switched it up and made it say f of x, again, this is just a function that I might have, okay? It is not in particular with whatever is in general. We just use a lot of function notation when talking about rules. And then once we look at the rules, then we'll jump into examples. So our first things first is that we've got the sum. And when we talk about the sum means to basically add. So you'll notice there I'm adding functions, okay? What you also can see is that if I talk about difference, we are subtracting functions. Product means to multiply, and quotient means to divide. Now, if I'm just adding functions, again, you're normally going to see this notation on the left-hand side, which is just going to see f plus g, and then evaluate it at something. So you're just going to say f plus x, f of x plus g of x, and just add those functions together. Same thing with the other ones as well. Now, with the subtraction one, I do want to add in that one's going to be a little in particular. You need to make sure to remember to put parentheses around this entire function here when you're doing the difference. It really matters when you've got a minus sign there. Now, if you have multiplication, again, the same thing. You need to be very, very cautious and make sure that there is parentheses around this entire function and this function. If they're one term, it's not that big of a deal, but if they're more than one term, it's going to be a bigger deal. Okay. With the quotient, again, it's just take two functions, divide them out. And again, whatever's listed on top is going to be the top function. Whatever's listed on bottom is going to be the bottom function there. Since f is on top, that's why f is here. And since g is on the bottom, that's why g is here. Now, whatever is on the bottom, again, don't know what it is, but whatever is on the bottom, we're just going to say that that function cannot equal 0, meaning its output cannot be 0. So whatever x value b plugs in makes this equal 0. We do have to kind of provide that that's in part of the ruling that we have. Since we are talking about, this kind of restriction here, that means domain is going to be part of our problems. So remind yourselves of some of the basic formulas that we used before. So we have our nice lovely parabola, which has got domain of all real numbers. We have absolute values, which has domain of all real numbers. We have y equals x, which is just a beautiful linear, which is a domain of all real numbers. You've got a cubic, which again, domain is all real numbers here. You also have a cube root, which is domain of all real numbers. Now I have 3 here that I have stars by, and that's because these are my special cases. Think of it this way. Is x underneath an even root radical? We don't care about this one because it's an odd root. This one is an even root radical. Anything that's an even root radical does have a domain issue at the very beginning, and it's going from 0 to a positive infinity. And then these two here, again, have that same thing. X falls in the bottom of the fraction. And again, if x falls in the bottom of the fraction there, again, I don't care what power it's raised to. If it's in the bottom of the fraction, there will be a restriction. And in my case here, because of x being in the bottom of the fraction, the restriction is 0 itself. You'll notice here that I put parentheses on 0. And the reason I put parentheses on that 0 is because I can't equal 0 itself. If I try to plug in 0 right now, currently in the bottom of this fraction or this fraction, I'm going to get basically what we call undefined. You can't take something and divide it by nothing, and that's where the open parentheses is there. However, here, if you'll notice when I plug in 0 here, it is allowed to, you're allowed to take the square root of 0, which is why I put a bracket on this number. Okay, be aware that these are not the exact straight numbers. We might have to do a little bit more math with them. And you may want to go back and review your domain and range information. There's a video already up in your course. You might want to look at another video just to look over the domain and range information. So f of x equals x to the third, g of x equals x minus 1. Find the following function and give their domains. So again, we're going to start with this and then we'll move on to this one here. So let's start with our first one, which is the plus. Again, notice it talks about there's a plus sign in between it. And what that means is basically what I'm going to do is I'm going to take this right here and I'm just going to rewrite this as basically f of x plus g of x. Now, the f function here is x cubed. The g function is x minus 1. Okay, and again, it's all of the f function plus all of the g function. And then in my case here, there's really nothing I can do. There's no like terms that I can combine. So that's it. That's my final answer. Now, when I put the subtraction in there, so in our case here, this is just taking the f function minus the g function. And you'll notice again, I'm taking exactly the minus sign in the order that it's written here. So that's why it's f minus g. Now the f function is x cubed, but the g function is actually x minus 1. Now because this second part, that g function is more than one term, this is where I said you had to be very cautious and make sure you put a set of parentheses there. And so I definitely want to put the parentheses there so that way I can remind myself that I am going to need to distribute, and we're going to get x cubed minus x plus 1 as my final answer. Okay, now we also have to determine the domain. Now remind yourself, an easy way to kind of check to see for the domain is ask yourself some questions. Okay, I have 5 questions that I like to ask myself. And the first question is basically, is x in the bottom of a fraction? If x is not in the bottom of the fraction, we keep moving on. Our second question is x under an even root? Again, if my answer is no, we keep moving on. The third question that you're going to ask is basically, is it a piecewise function? Okay. And your fourth question that you're going to end up asking yourself is it a word problem? Okay. Now be aware that we do have a few more things that will show up here with 1, 2, 3, and 4. There is actually a 5th question, and as you move into the higher level of math, you're kind of getting more questions there. So I always ask myself these questions first, and these are just basically what you're looking for. If x is in the bottom of a fraction, then we're going to have a domain issue. If x is under an even root radical, we'll have a domain issue. If it's piecewise, it's going to tell you the domain, so you don't have to worry about this one so much right now. And then if it's a word problem, all word problems have like a domain issue. So it's only where it's actually realistic. So in both of these cases, you'll notice none of them, basically I'd say no to all of these. So basically if no to all, then pretty much majority of the time, your domain is going to be negative infinity to positive infinity. Okay. Now, if it's yes to any one of those, we have to do a little bit of extra work there. But if it's no to all, then it's basically all real numbers. There are a few extra exceptions to this. So remember, I do have a couple of other questions I would ask later on. So like we'll add in a few more. So let's actually look at those and pretty much how would you write those domains. So we've got our functions and we already know like what they look like. Now remember, you can say all real numbers, but if I ask for interval notation, remind yourself that that's where that negative infinity to positive infinity came in when we talked about interval notation. Let's try with our multiplication and division now. So with the multiplication, we'll do that one first. We basically have the two things being multiplied together. So I'm literally going to take x cubed times x minus 1. Now, you'll notice kind of on the way that I have this written here, and let me erase that minus 1 because it looks a little interesting. The x cubed is one term, so do I really need the set of parentheses around that cube? No, as long as it's one term, you don't necessarily need the parentheses. But because I'm multiplying it to something else, the second thing has to have the parentheses around it. And in our case here, as you can see, it does have the second set of parentheses. And that's going to allow me to go ahead and distribute on through. So we should end up with x to the 4th minus x to the 3rd as that final simplified answer. Now with the division, it's just super nice and sweet. So again, always put whatever function is written up here at the top. So the f function is x cubed, and the g function is x minus 1. And guys, that's really all I can do. So that's as simplified as it goes as well. Okay, so now let's do our domain. Now on this one here, our domain, again, ask yourself those series of questions. Is x in the bottom of a fraction? Absolutely not. So we're good there. Is x under an even root radical? Nope, we're good. It's not piecewise, so, and it's not a word problem. So in this case here, my domain is going to be all real numbers. Okay. Now, what you'll do is you look at this one here. Again, is x in the bottom of the fraction? Well, yes, it is, because there's the bottom of the fraction and x happens to appear in it. So in that case there, we do have a little bit of an issue. So we need to go ahead and figure that domain out. Now, how to figure that domain is actually a little bit easier than you think. So ignore the top for a moment. Okay, so domain issue. And my domain issue comes from that x minus 1. And basically just take it and say like, okay, I need to know where it's not allowed to equal 0. So then we need to figure out where it does equal 0. So I'm just going to add 1 to both sides there. And I get basically x cannot equal 1. So my domain on this function here for my domain of f and g, it's going to be from -infinity to 1 and then 1 to a positive infinity. Now again, why am I doing the two separate things? Remember, it's everything but 1. So all numbers except 1. So I need to show that from -infinity to positive infinity like I have here. But to do that, I have to kind of stop at 1 and kind of stop it and show that it doesn't equal it. So that's where the parentheses come in and the little union symbol between the two. Okay. And as you guys can see, as you do these more and more, the better you'll get with it. It's really not that bad, but just make sure that you've got your domain down. Okay, let's keep going. So let's do a word problem. So the demand for a certain electronic component is given by P of X is equals 1,000 minus 2X. Producing and selling X components involves a monthly fixed cost of $1,999 and a production cost of $4 for each component. Now we're going to write an equation that models the total revenue as a function of the components produced in a month. Okay, so if you take a look at basically our function as we look there, what we're got to do is basically they've given me this P of X, which is what we call a demand function. So what is the demand for it? And X is basically producing and selling how many components we're producing and selling. So revenue is actually given by the combination of those two by taking the P of X function and the X, just X itself. So we're literally going to create that revenue function by literally saying that the revenue equals X times this P of X. Now, again, this is a little p, so it's representing our demand. And so basically, we're just multiplying them out. So in our case here, we're just taking X times. Now, again, P of X here has got two terms. So this is why I said you really need to be very cautious and use a set of parentheses here. Now, since I've got my parentheses there, I'm going to distribute on through. So that's going to give me 1,000 times X minus 2X squared. Okay, and that's basically my beautiful revenue function there. Okay, now, since I've got my beautiful function for my revenue, now we need to go figure out our cost function. Now, our cost function, they actually told it to us. It says producing and selling X components involves a monthly fixed cost of $1,999, and then the production cost of $4 for each component. Now, if you take a look at that right there in the wording that we have, one of the biggest things I notice is it talks about a fixed cost. Now, remember we talked about back in earlier chapters that if we were talking about a fixed cost, this did represent basically a fixed price. Then we start adding our variable price, okay? So the fixed price is normally our initial cost is very similar to what we would call the y-intercept. And then the variable cost, basically like, you know, the rate of the cost there is going to be our slope. So basically 4 times X will tell me what the variable cost for every single item I make. And then we have our lovely fixed costs there. So 4X plus $1,999 actually gives me my cost function. Okay, so now we have our cost function and we have our really pretty, beautiful revenue function. So the next thing we're going to do is determine, of course, the profit function. Now, remind yourself along the way as you have been working on these, when we talked about profit we said was a combination of cost and revenue. So remind yourself that when we talked about this, we said profit was basically revenue minus the cost, because you need to know how much money you're bringing in, and then we're going to subtract our cost. Okay, so since we know that basically our monthly profit is going to be this profit minus cost, normally we use function notation for this. Now this is very similar to what we have done previously. So this is where that R of X minus C of X is coming in. Now in our case here, again, remind yourself that when we have this -1, we always want to put like a set of parentheses. Now I know I'm drawing a brace there, but it can be a parentheses, a bracket, a brace, some type of grouping symbols to keep this part all together. Okay, now with that there, you're basically just plugging in what we had. Now remind yourself that the revenue function that we created was 1000x minus 2x squared. And then our cost function that we also created was that 4x plus $1,999. Okay, so basically we're just going to plug those in together there. Okay, so this is going to give me my 1000x minus 2x squared minus, and be super positive about the one that comes after the minus sign. It has to have this set of parentheses around it, because we have to remember to distribute the minus sign on through, which gives me 1000x minus 2x squared minus 4x minus 1999. And as I'm kind of working this, I notice that I have some like terms here and here, so I can add those together. And I'm going to write this as a minus 2x squared plus 996x minus 1999. Now, did I have to put the minus 2x squared first? Well, no, I actually did not. It's just helpful to have it there in the first bit there, because again, that's kind of like the variable that has the highest power. But it's not necessary that you have to put it there. Okay, so that is basically our profit function. So now that we have our profit function, let us go forth and actually find the maximum monthly profit. Okay, now here's the thing. We've actually looked at this before. So when we talked about maximum or minimums, think of it this way. This lovely function right here is quadratic. And anytime we talked about the max of a quadratic equation, okay, that was also called the vertex. Now we had a formula for the vertex. That was negative b over 2a, comma, f evaluated at negative b over 2a. And it was written as if it was a really pretty ordered pair. So remember, here was like the x value and here was the y value. Again, this is only if I'm looking for what we call a max, okay, or a min. So I can use the word max or min as I look at these. Okay, so let's give this a shot. As we work on this, remind yourself of that negative b over 2a. Now, remind yourself that when you're looking at this, that we ended up with our beautiful profit function was a negative 2x squared plus 996x minus 1,999. Okay, so remind yourself that this number is A, this number is B, and this one is C. So in the formula itself for a maximum of a quadratic, or AKA the vertex, we started by finding negative B over 2A. Okay, so in our case there, that's going to give us a negative times 996 divided by 2 times negative 2. And when you simplify that out, you should get 249. Okay, now with that 249 there, do remind yourself that you are looking for the maximum profit. So this basically tells me X, which is the number of items that I have sold. So now I need to take this number of 249 and plug it back in to my profit function to actually determine what the maximum profit is. Okay, so that means that I'm basically taking that formula, negative 2 parentheses squared plus 996 parentheses minus 1999. And again, this is where I'm going to plug in that X value of a 249 that I've just figured out what it was. And then when you do that, you should end up with $122,000 and $122,003. Okay. And that's it. That's our maximum profit. So let's try this again and let's go for what we call the average cost function. Now, so Sunny Greenhouse produces roses, and their total cost for production of X hundreds of roses is C of X equals 50X plus 500. Now I want to know what the average cost function is. Now remind yourself of how to find an average. So if I gave you, say, 3 exams, so we'll say like test 1 plus test 2 plus test 3. Basically you would take them all and divide by 3, right? Add them all up and divide by 3. But this would mean that you'd have to know what they are, right? Now, in our case here, I'm asking for your average cost. So basically I need to take the cost and divide by our number of items, right? Now, in our case here, we don't actually have like individual costs that I have. All I have is a formula. So in our case here, I'm just going to use, instead of, a number, I'm just going to say 50X plus 500. Now, what variable did we allow be the number of items? Well, the number of items, that's what X was. Okay. And so when we actually look for what we call our average cost is actually a pretty nice formula. So again, the key word here is average. So if I ask you for the average cost, you're going to take your cost function and divide it by X. Now, normally when we talk about average cost, we represent it using this kind of formula notation of C of X over X. And then I'm just going to write the formula for cost, the notation I used, but I'm going to put a line over it, the top of the name, just to let me know that this was an average. And this can actually be repeated for anything. So if I say for my average profit, I would just take the profit function and divide by X. Again, take your profit, whatever the profit was, divided by how many items you produced itself. Okay, be aware that these X's cannot cancel out because this one is inside the profit function. So it's the profit function evaluated at this. So this is one big thing, but it's divided by X. And again, I can just put that little line over it to determine that this is the profit. I can do this also for revenue or anything else that I need. Okay, so basically what we're going to do is we're just going to do that and divide. So literally you're just taking your nice lovely 50X plus 500 and divide it by X. Okay, now they're going to talk about it as calling it this identity function, but guys, it's literally just always divide by X itself. So whatever the items being produced, since we said that X was the number of items being produced, that's literally all we're looking at there. Okay, and again, that's it. There's really nothing else you can do. This is basically your final answer. You just kind of leave it in this really cool fraction. Now, for basically this problem that I'm looking at, we just defined what the average cost was. Now, my average cost here, again, with that function is basically the cost function all divided by x. Now, we've created this new world function, but now we have to talk about its domain. So for what input values is this actually defined? And we want to actually give a real world explanation of why we have this answer. So remind yourself, the first thing I talked about in our domain issues was, did x fall in the bottom of a fraction? And in this case, it definitely falls in the bottom of a fraction. So because it's falling in the bottom of a fraction, we know basically that x is not allowed to be 0. Okay, and where did x come from? Again, it's just the bottom, whatever that bottom is. Basically, when we start looking for any restrictions, we know straight away that the bottom, whatever the bottom of the fraction is, the bottom of the fraction is just not allowed to equal 0. Okay, in my case here, I just literally have x, so I just put x and I say not equal 0. But we are also in the world of the word problem. So we know it can't equal 0, but because I'm in a word problem, I have to really kind of think about this in terms of what it could be. Now, first of all, let's think about what x is. X is the productions of hundreds of roses. So first of all, can I have negative hundreds of roses? No. So this right here, just even thinking about it, basically tells me that x has to be a positive number. Okay, and we know x is not allowed to equal 0. Okay, so straight away we know x cannot be 0 because that will basically make that bottom undefined. And we know x has to be positive due to the fact that we are talking about producing roses. There's no such thing as a negative rose. So in that case there, that is basically what our real world answers need to be. So in looking at all that, and let me put it in kind of more written terminology here, the average cost is going to be defined by any number that is positive or greater than 0, because producing negative roses is just not even possible. We also know it cannot actually equal 0 because, again, I'm dividing by a variable there, and that bottom itself is never allowed to become 0. So since x is the only thing in the bottom, that basically means that it just cannot be 0 itself. And if you really think about it, basically, if you have nothing, you produce nothing, you're not even going to have a cost. Like, it's just, you did nothing. Okay. So let's actually graph this. And because we just figured out kind of the idea that we're looking at, let's graph it from 0 to 5,000 roses. Now, even though I said 5,000 roses, remember x is always in hundreds of roses. So if I look at that, that really means I'm actually looking from 0 to 50. Okay, and what is that average cost? So I would take my graphing calculator and I would go into y equals. So let's pull the graphing calculator over. Oh, I did not mean to make that large. Okay, and I'm going to go into y equals, and I'm actually going to put in the fraction. Now, again, I'm going to put this in twice just because I want to make sure that my TI-83 people understand how to put it in. But for my TI-84 people, you have the option of basically, once you're in y equals, if you'll hit the alpha button and then y equals again, you have the ability to put it in as a fraction and make it look like a fraction. I strongly recommend that if you have this ability, go ahead and use it to your benefit. For my students that don't have the ability to make fractions, so the people that have like a TI-83, what I strongly recommend is you need to put parentheses around the entire top of the fraction, and then close the parentheses and hit the division sign, and then put parentheses around the entire denominator or the bottom of the fraction. Okay, they'll look exactly the same, but I do want to just kind of keep that idea there. Now, again, we are graphing from 0 to 50. Okay, and we are going to kind of look here. Let's put this at, like, say, -1. And then my max, well, let's see, we're talking about the cost. So we know that it's going to at least be 500. Let's see if it's any bigger than that. Oh, and so like 500 seems to be a really good explanation there. And again, as you saw, it drew the blue first and then the red, because again, I entered it in two different formats. So you were able to see that. Again, depending on who you have, if you've got a TI-83, you're going to be the red one. If you've got the TI-84, you want to go ahead and try to get into the ability to put it as that beautiful fraction. Okay. Okay. So that works really nicely there. Now, basically my Y value, I kind of have a little bit of leeway with it. So you can kind of basically change it to whatever you want. But your X value, basically, they kind of told you that they wanted it from 0 to 50. Okay, so what can we actually say about the average cost? Well, after I've graphed it, I can see that basically the average cost looks like it declines. Okay, basically it goes down, the average cost goes down the more I produce my roses. So the more roses I have, the cost seems to like go down, which makes sense. So let's talk about composite functions. Now, this one a lot of people remember as Fogg and Goff. It's a little bit different than the multiplication. So let me kind of bring that back up in the notation real quick. So when we were talking about the multiplication, this would be multiplication, and this would just be f of x times g of x. Now you'll notice I have written it with this dark circle, and it's got a closed circle there. So like it's closed. There's not an open circle, it's colored in, okay? Normally when you see people writing really fast, they just put like a dot there. And then this that has the open circle is different, okay? This is literally the composition. So open circles have to be filled. So this is why this looks a little bit different. So this right here is basically looking at your product. And this one is going to be my composition. Okay, so what's the big difference between composition versus multiplication? Well, multiplication, you're just multiplying two functions together. A composition basically means that you're taking one function and putting it inside of another function. Now, that is going to kind of give us a little bit more to deal with the domain. So the domain of f and g is basically the subset of the domain of g for which f composed of g is actually defined. Now, this is only if the g is on the inside. So if we say f composed of g, then we are talking about it's the subset of g that defines it for f composed of g. And if you go the other direction with it, so if I say G composed of F, in our case here, G composed of F, the one that's listed second is the plugin. So that's the one I would plug in here. And so it would be G with F of X plugged into it, which means the subset of the domain starts in F. Okay. Be a little cautious of the order on which it is written. A composite function is basically thought of a machine within a machine. So like you've got the machine is basically the whole thing is a function itself, but you plug in X and it goes in the door, but inside the first door, it has to go through G. And when it comes out, it becomes G of X. And then once you've got G of X, you now plug it into the F function, that Y value, and goes into that F function there. So it becomes, it was a Y value, but now it's a domain of the F function. It gets plugged in there, and that's where you get that F composed of G of X, okay? And again, it's very, very important to note which one is written first. So let's try this way. So for the following composite outputs, we're going to use f of x equals 2x minus 5, and we're going to let g of x equals 6 minus x, and we're going to let h of x be 1 over x. Now, once we have figured out what the new composite function is, then we want to look at the domain of it, okay? And I'll kind of give you a good idea of like what to look for the domain issues. So let's look at h composed of f here. Now, again, you'll notice I did not use G first. I said H composed of F. Again, I can let these be any names of any function. So this is why it's, even though people memorize it as Fogg and Goff, it's not always Fogg and Goff. Fogg and Goff is just a notation to help you learn it. It's just a very in general version of it. So this is H composed of F. This basically means that you're going to take the H function and you're going to plug in the F function. Okay. Now, what I suggest to do, again, everybody is slightly different. What I do like to see people do is if you are a visual style learner, go ahead and get yourself a different color. So that way you can practice plugging in and it makes it very obvious when you do your plug-in. Okay. And I would always kind of pick a color for one thing versus the other. So the H function, this was my beautiful H function here. So we're going to say 1 over X, but instead of X, I'm going to put a set of parentheses because I'm going to plug in the entire F function. Now remember, this was the F function. So that is literally what we're going to plug in. Okay, and that basically gives me what my answer is. So H composed of F evaluated at X is this whole new function here, 1 over 2X minus 5. Now, in order to do the domain, we're going to start with basically right here. Was there a domain issue? Okay, so was there any domain issue to begin with the F function? So I go back up to my F function and my F function here was basically 2X minus 5. And again, I'm going to ask myself that series of questions. Is X in the bottom of the fraction? No. Is X underneath an even root radical? No. So in the beginning part, there is no issue. However, once you've said whether or not there is a domain issue to begin with, then we go to this function and what is the domain of this? Now, in this one here, the first thing I begin to notice is that X does fall in the bottom of the fraction. So because X falls in the bottom of the fraction, I'm going to take whatever's in the bottom of the fraction and say that it cannot equal 0. Go ahead and solve that out. So I'm going to start by adding 5 over, then divide by 2. And we get X equals 5 over 2. So that's basically what X cannot be. Okay. And that right there basically is my domain. My domain is everything but that one number. Let's try this again. So let's go a little bit differently. Let's go F composed of G. So let's kind of go in the route that most people think of it. So again, kind of pick out your colors. Now, I previously had started off with the F function being G. So remind yourself that as you're working it, that's basically the F function. And then I'm going to let the G function be, let's do it purple. Okay. So we'll put the G function inside here. Okay. Now, you'll notice that instead of writing it as this format here of where it's kind of this F composed of G of X all kind of in the same line part there, I do like to write it with the big F on the outside and the G of X I kind of make smaller on the inside. One, this allows me to identify visually the smaller item to be plugged in. If I don't have, say, different colors that I'm working with. 2, it also allows me to really kind of visually see that it's being plugged in. But if I have the colors, I can see that visual contrast. But in case I don't, that is why I kind of chose the route I went with it. Now, remember that the F function was 2X minus 5. Now, again, you'll notice I'm not writing what X is. I went ahead and straight away basically put a set of parentheses where X is. And then inside the X, I'm going to put the entire G function. Now, remember, I kind of said that the G function was this purple color. Okay. And I basically said that the F function was this green color here. So that's why you see those two different contrasts of colors there. And again, this basically is F composed of G evaluated at X. Now, if you can simplify, let's go ahead and simplify, and I can simplify really nicely here. I'm going to go ahead and distribute my 2 on through, which is going to give me a 12 minus 2x squared. And then we don't forget we have this beautiful like minus 5 over here. And then I notice I have some like terms that I can combine very nicely. And so I'm going to end up with a 7 minus 2x squared. Okay, now if you want to rewrite it as basically a negative 2x squared plus 7, both of those are going to be counted correct because they are technically the exact same answer. Now, let's talk about the domain of this one, because this is where, again, a lot of people make that mistake with the domain. So we always start with the inside function. So the one that you're plugging in, which is our g function here. And so I go to the g function here and I go, are there any domain issues on that function? Well, is x in the bottom of the fraction? No. Is x under an even root radical? No. Is it piecewise? Nope. And this ain't a word problem, so we're still good. So we pretty much can say that we have all real numbers. So then I go to the function I have here. Okay, so I have no issues to begin with. So now we kind of repeat the process. Is there any x in the bottom of the fraction? Is there any x under an even root radical? Same piecewise, it's not word problem-y. So basically, there's no restrictions on any of this. So my domain gets to be all real numbers. All right, let's try this again. Again, this is kind of where the practice is going to really, really help you. And again, as you're working your way through these, if you've color coded these, it really does help. So I'm going to remind myself that for this one here, we're going to take the g function, okay? And my g function is 6 minus x squared. And inside my g function, I am going to put the f function, okay? So, and again, how do I know which one I'm putting in? It's always the one that's listed second. That is the one that is going to be put in because it's, again, the one that's after the word compose. The little open circle means composed. So everywhere I see x in the original function, I'm basically plugging in that 2x minus 5, okay? Again, your choice if you want to put it this way where you've got that 2x minus 5 inside, or you can still use that function notation. You'll notice a lot of the times they're going to put that beautiful function notation when they start off any explanation. But again, you can kind of tweak it as long as you understand what that function represents there. Now, if you can simplify, go ahead and simplify. If you can't, this is not horrible, but I am going to remind myself that when I see 2x minus 5 there with a exponent on the top, that is basically multiplied out. So you're going to end up foiling that out, but I'm also going to put a big old set of brackets around this. So because it's minus that whole multiplication. Multiplication comes before the subtraction. So as I multiply that out, everybody should have gotten 4x squared minus 10x plus 25. And then I'm going to go ahead and distribute the minus sign on through. Okay, so now that we've got that done and simplified it all the way out, I ended up with a negative 4x squared plus 10x minus 19, which is really nice. And again, as I'm going through this, I'm going to start with that innermost function first. So the one that's always listed second, and I go to it and I look and I go, oh, does it have any domain issues? X is not in the bottom of the fraction. X is not under an even root radical. X is not in a piecewise function. It's not word problem. So literally no domain issues. Okay, once I've checked the inside function, always check the inside function first, then we check the completed function. And again, ask yourself that series of questions. Again, in our case here, there's absolutely nothing. So its domain is all real numbers. I did want to make a little bit of a technology note here, and that's just because with technology, yeah, you can use the calculator to help you out a little bit, but be aware the calculator is not going to do any of the algebra style for me, okay? The calculator will only help when you are trying to evaluate functions at numbers. So that will be really great to do, but it will not actually tell you what the combined functions actually are. So if I were to give you some functions, so let's say f of x is going to equal x squared plus 2, and g of x is equaling, say, 3 minus 4x. Okay. I can use the calculator to show me what the graph looks like if I were to combine them, but the calculator will not tell me what the addition of these two functions are, okay? It literally will not tell you that. So I will actually have to do this part by hand if I ask you for what is the function that actually gives you the combined functions of these two. But I can make it graph this. So let's actually take a peek at that. So let's go get our graphing calculator again. Okay, and I'm going to go into y equals. I'm going to clear out everything I got here. And we're going to start by graphing in y1 the f function here. So I'm going to plug in my x squared plus 2. Oops, meant to put that in y1, sorry. So x squared plus 2. And then in y2, I'm going to plug in the g function, which was 3 minus 4x. Okay, now in y sub 3, what I'm going to do is I'm going to have it actually add these two together to create my new function. So I'm going to actually use some of the calculator notation. So I'm going to hit alpha trace, and I'm going to say y1 plus alpha. Ooh, hang on, go to. There we go. Okay, so I've got y1 in there, and then I'm going to hit that alpha trace one more time and plug in y2. Okay, those of y'all with the TI-83, let me have this conversation. You guys can use these little y1 and y2 inputs. So as you saw how I did that really quickly, those of y'all that have an 84, it's literally a pop-up menu. And so you can put in y1, and then you can do the same thing and put in y2. For those of y'all that have the TI-83s, again, I totally recommend just do this by hand. It makes it a lot easier. But you can use the calculator to do this. If you want to put in the y1 and y2, you have to vars, y-vars, function, y1, and then plus, and then vars, y-vars, function, y2. It's a lot more steps for my TI-83s, whereas my TI-84s have a pop-up menu, which makes it a little bit easier for them. Okay, and so you can graph them. So you can see what the two different, and let me just hit zoom 6 here. So we can see here that x squared plus 2, that was that first one that graphed there. And then we can see that the 3 minus 4x, which was the straight line there, we see it graphed there. And so when I start adding these together, this is that black line is the combination of the two. Now, if I were to, and let me go ahead and do this, plug in what we wrote physically out. So we did this by hand. So the x squared minus the 4x plus 5. Okay. Notice that it's going to graph right over that combination of the y1 plus y2. So you're going to get the same answer either way, but I do recommend to kind of just go ahead and still do it by hand, even though you have a calculator that will kind of work this for you as you go through this. Okay. Now, yes, you can use the calculator to input different X values to get that way. Again, I do strongly just recommend to kind of do this by hand. It's not necessarily easier by calculator. It's way more work. So if I were to say, well, what is F plus G evaluated at, say, 3 here? Okay, basically what that means is you're taking the F function evaluating at 3 and the G function evaluating at 3. So you can either plug it in right here, or you can take it individually. So I can basically kind of do 3 squared plus 2, and then I can add that to the 3 minus 4x times 3 there. Okay, and in our sense there, as we kind of do that math, do the innermost grouping symbols first. Okay, so you've got the 3 squared plus 2, which is going to give me a beautiful 11. And then you've got the 3 minus 4 times 3, which is going to give me -9. And when I add those together, I end up with 2. So my final answer here is 2. Now I can easily take this same equation here and evaluate it at 3. So because that's literally what F plus G is. F plus G is this new equation. So I can put in 3 squared minus 4 times 3 plus 5. Okay, so if I do 3 squared minus 4 times 3 plus 5 in the calculator, you'll notice that you'll get the exact same answer of that's going to equal 2 as well. So you have multiple options when you evaluate them at numbers. Would the calculator method be easier? I'm not 100% for the calculator on this one, just because it's actually quicker to do this by hand unless you're very proficient with the calculator. And this is not a skill that a lot of people use with the calculator. Even in higher level math, we don't really use this skill unless you're very, very much doing a lot of information. Like, you have to do a lot. So I totally recommend just kind of do it by hand. If you're struggling with the domain, be sure to go ahead and watch the video for domain.